Hi guys, we're going to start this video with our types of functions notes. The topic coming up is describing transformations of a function from the parent function. And to do that by a graph, it's helpful to know what key feature of the graph to look at. Some of these are easier than others. So for example, linear and cubic, I would probably give you the original function on the graph and then also the transformed copy, so you have a visual to see how it changed. But certain functions, like quadratic for example, you can tell that a quadratic has been reflected because this one is what the original copy looks like. All of these, the positive graph is what the parent function looks like. The parent function for all of these is positive. So if it looks like the negative copy, then your graph has been reflected over the x-axis. Some of these it also could be over the y-axis. But for a quadratic function, the vertex of the quadratic function is how you would tell me if the graph got shifted left or right, or up or down. So the transformation form of a quadratic is going to tell you where the vertex is. Cubic and quartic, it will be hard to tell from the graph.
Ms. Cozart, could you please dial 1142? Ms. Cozart, could you please dial 1142?
Sorry about that announcement, guys. Exponential, it will also be hard to tell from the graph. But you can find the horizontal asymptote, and the horizontal asymptote will at least tell you if it's been shifted up or down. You'll be able to see that it's in a different location. Absolute value, same as quadratic. You will use the vertex to figure out if it has been shifted up, down, left, or right. For a radical function, you can use that initial point to figure out where it's supposed to be. Piecewise, I would have to give you the original copy and then a new graph, and you figure out the difference between the two. And trig, we're going to spend a lot of time on trig graphs by themselves. So for this particular unit, I'll probably give you the original copy so you could see if it's been shifted up or down. We're not really going to use trig too much. So we will work together on some of the graphs. But we are going to figure out in this video how to tell the transformation from the equation. Alright, so if you're watching this video, you should have already done the Desmos activity where you investigated what A, H, and K did to the graph. So A did a couple of things. Alright, so we are going to fill those boxes in when we zoom next, so pause the video, at least copy those down. Alright, so here I have a function, and I need to be able to tell all the transformations that have happened between this function and the parent function. So you need to know what the original equation looked like. So since this is a square root equation, the parent function is just the square root of x. So if I look at the new equation, that's the only thing that is the same between this copy and the parent function. So that means this 2 has done something to the graph. This x minus 1, the minus 1 has done something to the graph. And the plus 6. The plus 6 has done something to the graph. So we have to figure out what those are, and it's using this investigation from the Desmos activity. So one of the things that you should have noticed about the number in front of the function, that if it's bigger than 1, it's called a vertical stretch. And if a is less than 1, and by that I mean like a fraction, so not negative, but if it's between 0 and 1, it's called a vertical compression, and those are in the Desmos activity as well. So we have to be able to look at this and figure out whether it will make the graph skinnier, which is a vertical stretch, or appear wider, which is a vertical compression. And you have access to Desmos, so you can type this into Desmos with the parent function, so you can see the difference between the two. But since 2 is bigger than 1, this is going to appear to have been stretched vertically. So it's going to look like if you took the parent function, grabbed a hold of it, and pulled it up. That's what it'll look like. All right, minus 1. So with the Desmos activity, it was a little bit hard to tell because you had so many negative signs floating around. But basically, if you see a minus in here, it's actually going to shift it to the right, and a plus will shift it to the left. It was hard to tell in the Desmos activity because when you had a positive, it showed you like plus negative, and when you had negative, it showed you negative negative, so it might have been a little bit hard to tell. So since this says x minus 1, minus will move this right 1. And k, you should have noticed that it moved up if it was positive, down if it was negative. So this plus 6 will also shift the graph up 6. All right, so you probably want to fill those in and write that down so that you can reference that for the rest of the examples. We'll do a few more in this video. All right, so you should be able to recognize that this equation is cubic because it has the power of 3. So the parent function is x to the power of 3, which means this is not a transformation. Those two things are making it cubic. Everything else is a transformation. So negative actually does its own thing. The fact that there is a number in front does its own thing. This plus 2 that's with the x is going to do its own thing. And the minus 4 at the end is going to do its own thing. So you should pause the video here, see if you can figure out all those transformations, and then check and see if you got it right. So a negative out front will reflect it over the x-axis. 1/2 is smaller than 1. So this graph will appear wider than the original. It'll kind of look like if you took one of those squishing machine, like the hydraulic squishing machines, it made the graph go out because it was being squished. The +2 will move the graph left 2, and the -4 will shift the graph down 4. All right, so I'm going to give you one more example that I would like for you to write down and try. All right, write that one down, try it, and be prepared to answer it on your own.